Hey guys, it's Mary and welcome back to Study Journey. Welcome back to the Python series. This is episode 3 of the Recursion Problem Set series, and in this episode we're going to be starting on part B, which is Caesar cipher, and we're going to be starting on the first part of this problem. So without further ado, let's get into the video. Okay, so in the previous episode we finished part A of the Recursion Problem Set, and now we're going to be moving on to part B, which is cipher like Caesar. So Caesar cipher is a way to encrypt messages and also decrypt messages by picking an integer and shifting every letter of your message by that integer. But first, let's review some vocabulary. So first, encryption is the process of obscuring or encoding messages to make them unreadable. And then decryption is the opposite of that. So it's making encrypted messages readable again by decoding them. And then cipher is just an algorithm for performing encryption and decryption. Plaintext is the original message before this shift, and then the ciphertext is the encrypted message. So a ciphertext still contains all of the original message information, but it just looks weird because it is not like the regular letters. So like I said, it's basically picking an integer and shifting every letter of the message by that integer. So if, for example, the shift is k, then all the instances of the ith letter will be I plus k. And then we had to be careful if it goes past 26, so if it is at the end of the alphabet, because then it will go back to A. And also, uppercase and lowercase letters are treated individually, so that uppercase letters are always mapped to an uppercase letter, and then lowercase letters are always mapped to a lowercase letter. So if, for example, the uppercase letter maps to A, then the same lowercase letter should map to A. And then punctuation and spaces should be retained and not changed. So if there's a comma, then just put the comma there and don't change it. So, for example, here's an example right here. So if we're shifting A, B, C, D, E, F by 2, then A would go to C, and then B would go to D, C would go to E, and then D would go to F, and then etc. And we can see the answer is right here. And then also hello world, as we can see if we move it four places, the letters are changed. The uppercase letters are still uppercase, the lowercase letters are still lowercase, and we still have the punctuation and spaces as there is. And then here it is for the space. If we shift it by any value, a space is still a space. Okay, so now we're going to be talking about classes and inheritance. So this is the first experience coding with classes, and we're going to be using two subclasses. So plain text message and ciphertext message from the message class. This method could be used to apply a cipher to a string, etc. So when you complete this implementation, you can either create a ciphertext message or you can encrypt your own plain text message. So message contains methods that could be used to apply a cipher to a string, either to encrypt or decrypt a message, and the Caesar cipher decrypts and encrypts with the same action. Plaintext message has methods to encode a string using a specific shift value. And our class will always create an encoded version of the message, and we will have method for changing and encoding. And then the ciphertext message contains a method used to decode a string. So, like I said, when you finish this implementation, you can either create a ciphertext instance using an encrypted string that someone provides you and try to decrypt it, or you can encrypt your own plaintext message instance and then create a ciphertext message instance from the encrypted message within the plaintext message instance, and then try to decrypt it and see if it matches the original plaintext message. So our job will be to fill in the methods for all three of these classes according to the specifications given in the docstring in this document over here, ps4b.py. We do not have to use recursion in this part, but we can if we want to. There are a couple of helper functions that we have implemented in here, so like load words and isWord. So we may want to use these in our solution, but we don't have to completely understand them to use them. But we should read and understand the helper code and also the rest of the file, and then use it as a guide for our solution. So in this episode, we're going to be doing part 1, so message. It says to fill in the methods of the message class found in ps4b.py according to the specifications in the docstring. So let's scroll down and we can see right here is the class message, and it contains an object. So first we must initialize a message object, as it says right here. And the message object has two attributes: self.message_text and self.valid_words. So we can delete this right here and replace it with our code. I'm still going to change everything to tabs. Make sure it is in tabs. So everything is uniform. And seeing that these should be tabs, I'm just going to make sure once again, because we want to make sure that all of our spacing is the same or it's going to cause errors. Okay, so let's start right here. So first we have to initialize the object. So it has the definition of initiate with self and then text. So it says that self.message underscore text is a string determined by the input text. So self.message underscore text is going to be the text. And then self.valid underscore words is equal to load words. And then we're going to get the word list. And now next it says that the get valid words should return a copy of self.valid underscore words to prevent someone from accidentally mutating the original list. So right here it says for get message text, it says right here that we should return the self.message underscore text. So here we're simply going to return self.message underscore text. And then next for get valid words, it says use to safely access a copy of self.valid words outside of the class. And this helps us avoid accidentally mutating class attributions. And we should return a copy of self.valid underscore words. So here we're going to return a list self.valid underscore words. Okay, so now we have done the basic part of part 1 of message. So in the next episode, we're going to finish this and talk about build, shift, dict, and then apply shift. So this is actually going to be using what we have before and actually creating a dictionary that can be used to apply a cipher to a letter and then applying it. So we're going to apply the Caesar cipher to the message.